Hello to all you participants of the Berlin Science Week 2022 and welcome to my talk on our current research project Reincarnate, where we aim to anchor the idea of the circular economy in the European construction industry and significantly extend the life cycle of buildings, construction products and materials through innovative solutions. On the long term, this is an approach to reduce construction wastes by 80% and the CO2 footprint of the construction sector by 70%. My name is Sabine Kruschwitz and I'm a junior professor funded by the Bundesanstalt für Materialforschung und Prüfung at the Technical University of Berlin. At TU Berlin, I represent the division of non-destructive building material testing at the Institute for Civil Engineering, while at BAM I lead a junior research group in the 8th department, non-destructive testing. With our work, we focus on the non-destructive material characterization and informatics for the sustainability in civil engineering. I start off with a quiz, or rather question. Who knows the German overshooting day and knows when it was in the year 2022? Feel free to participate in the quiz. It is possible at any time and completely anonymous. Let me explain what that actually is. The overshooting day is the day when the sustainably usable resources that our Earth, our ecosystems, can produce in 1 year are used up. That means it is the day we have put more carbon into the atmosphere than forests and oceans can absorb in 1 year. We have caught more fish, cut down more trees, harvested more, and used more water than the Earth and its ecosystems could reproduce in the same amount of time. According to the Global Footprint Network, the German population currently uses many times the natural resources available on a global scale in 1 year. And accordingly, if all people worldwide lived the way we do in Germany, we would need several Earths to sustainably meet our resource needs. How many Earths do you think that is? In this chart, you can see when other countries reach their overshooting days. I deleted Germany to keep it exciting for you. You'll find out the answer after you vote via the link. My presentation today is specifically about the construction industry. This is one of the so-called key industries. Many people are not aware of this, but this is the most resource-intensive industrial sector that we have. According to a report of the Intergovernmental Panel on Climate Change, it is responsible for 25% of the global CO2 emissions, 50% of the raw material consumption, and interestingly, also 40% of the waste. By the way, 7% of the CO2 footprint are process inherent, because in order to produce concrete, our mostly used building material, we need cement clinker, which basically acts as the fundamental hardening component in the mix. And in order to produce clinker, we burn limestone, a process that releases carbon dioxide as a byproduct. So, the building sector, if it was a country, would be the third largest emitter of CO2 after China and the USA. This is frightening and calling for a change, isn't it? Conclusion at this point. The world is not enough makes a good movie for sure. In real life, however, we are heading for quite a catastrophe. And this is mainly due to the consumption of the major industrial nations. Less developed countries currently have a much smaller ecological footprint, but many of them are developing rapidly, and it is very clear that we all, and especially regions like Africa, India or China, which are growing rapidly, must rethink their resource-intensive key industries and make them more environmentally friendly in order to keep our planet livable for future generations. And we must understand this as a global challenge, After all, we all live on the same planet, and there's no planet B. For sure, the global climate crisis and resource problems have been recognized and they are fought against by individuals and politicians. Ambitious national and international targets have been put in place, the Paris Climate Agreement, the EU taxonomy, and the aim for so many countries is to become climate neutral by 2050. The problems of the building materials sector are discussed in the press, like shown here, and in the society. There are countless magazine articles and the topic is widely broadcasted and discussed in television. But what is the right way to go now? Once again, what exactly is the problem? Let's wrap it up here. Our Earth is a closed system. All substances, all materials exist in a certain amount. There are basically limited editions. We can make goods for ourselves by creating new compounds and changing materials by putting them together, but we cannot recreate matter in that sense. For the building industry, that means first, we produce building materials, mainly concrete, for which we have to produce cement with a high carbon footprint and consume resources like sand and gravel. We construct buildings and traffic routes, infrastructure from it and use them on average for some 30 to 40 years, after which they have to be repaired or partially demolished. We demolish our buildings again and then downcycle them and use the material, for example, as road filling or landfill the rest. The whole thing is material-wise a one-way street and leads to the fact that our Earth warms up and valuable resources lie on expensive landfill after a certain period of use. And this is what it looks like then. In Europe alone, we produce millions of tons of mixed construction and demolition wastes. Most of them end in landfills, like I said. The material cannot be used because it's not sorted according to type. In some cases, it contains adhering compounds. There is simply no established information, deconstruction or sorting and recycling cycle that helps companies and individuals to reuse it. The stock of buildings and infrastructures at around 30 billion tons is now a significant man-made storehouse of raw materials. But right now, our waste is a material without an identity. But what we must consider on top of the massive resource requirements, also almost half of the total CO2 footprint we have in the construction industry is caused by the materials itself. The other half is caused by the operation of the buildings, that means heating or cooling. What can we improve on the material side to use less CO2 and resources? It's two things. First, we need to develop new cements and concretes that emit less greenhouse gases due to the process. Secondly, we should recycle and reuse as much material as we can that is already produced. That saves resources and CO2 at the same time. Thus, factors such as the origin and nature of materials, as well as the general impact of a building project on the environment, have become into massive focus in the recent years. Buildings and infrastructure are envisioned to become networked, flexible, recyclable, healthy, and energy positive. Following the cradle-to-cradle idea, they would be designed to be variable and repurposable. Their materials should be easy to dismantle, separable by type, and fully recyclable. This would turn buildings into long-lasting and valuable raw material depots that release resources at the end of their service life. Thanks to this principle, they make a significant contribution to maintaining the value of the property. The idea of the so-called urban mining is born. And that exactly brings us to the goals and mission of the Reincarnate project. This is a European research project, so let's take another look at some numbers on this level. The average lifespan of a building in Europe is only 25 to 30 years, and the main reason for demolition is obsolescence. This is why there's a large amount of construction and demolition wastes, representing approximately 25 to 30% of all the waste in Europe. The mission of Reincarnate is really to anchor the idea of the circular economy, the cradle-to-cradle concept in the European construction industry, and to significantly extend the life cycle of buildings, construction products, and materials through innovative solutions. This would reduce construction waste by 80% and the CO2 footprint in the construction sector by 70%. Reincarnate brings together 16 multidisciplinary organizations from 8 countries, including industrial companies, universities, non-profit organizations, and research institutes such as BAM. I think you all have noticed. We currently have 3 big mismatches in the building sector when we aim towards a circular economy. First, the demand increases globally for building material, while the natural resources diminish. At the same time, the building and construction wastes are rising, but this can be thought of as a material stock actually, and the math is that about 80% of the material we will need for the next 50 years of construction are already built. But right now, we even pay money to deposit this resource. Second, the quality mismatch. We typically have increasing quality requirements while our building stock is constantly decaying. Third, the information mismatch. We don't have any information at all where the materials are in our urban building stock and what their condition is. There is no information platform really for people who want to reuse the material and help preventing the waste to pile up. So let me explain you these mismatches and the lack of information with a very easy to understand story. Let's think of this little fish living happily in his newly built house. But after some 30 to 40 years, he feels like something is wrong. After this time, he feels like the house is too tiny, its quality has degraded, or he simply has new requirements to feel well in it. So, what does that mean? We have a building, a fishbowl, or a building part, which decays in quality over time. If it does not fit anymore the requirements that it was intended for, we can assess it and refurbish it, for example, by adding or replacing parts. Like in this little figure here, well, the inhabitant maybe has changed or some parts of the building have changed to make it fit our actual requirements. When it decays further and cannot be used anymore in its original function, we can have again an assessment and a decision-making process and find alternative ways of using it with other requirement functions. In our case, the fishbowl building could have a second life as either a beautiful artwork, a drinking glass, a candle holder, or we can take it apart and use the glass beads for scientific experiments. All just examples, of course. But do you see? We need an established information flow over time here. What is the fishbowl made of? What components does it have? What is their condition, etc., etc. So we need ways to get all this information together and make it accessible. And this is the very core of Reincarnate. The core is a circular potential information model. And here we are developing an information system pretty much like a building information model, but with a strong focus on the circular potential of the components that allows us an evaluation of a building's circular potential, the reincarnation of a building. We call it CPIM, will allow to store and capture all required data to understand the potential to extend the lifetime of a building, its building components and materials, and to find optimal reuse possibilities for each of its elements. It will also enable to trace construction products and materials across different buildings, waste management steps, and construction sites. So basically, it will really establish all the necessary connections to important information, data, and agencies involved for reuse. It is complex, of course, but look, it will, for example, consist of a digital twin platform, an interface to feed data from objects and other tools to do case-specific circular value flow planning. We have 10 key innovations encompassing digital tools for materials and waste tracing, automated solutions for deconstruction and waste separation, cross-sectorial communication, and the value assessment of recycled materials. On the next 2-3 slides, I explain a little more in detail what will be the focus of the work that is contributed from BAM. Basically, we will be active in 2 fields, which are highlighted here in green and blue. The green innovations are supported by working with NDT methods and feeding important information to the CPIM model, our heart, while the blue innovation is supported applying our self-developed AI software, artificial intelligence, to find high-quality recycled building materials made from wastes. Here you see how we add new and valuable information to CPIM with non-destructive testing methods. We carry out these methods either on-site directly, on the building part, or after taking course in relevant and representative areas of it. Which means we can also measure in the lab and then feed the information. We can just work with one tool or use a combination of methods and then combine as many complementary information as we have, like usage, position, known damages, history, adaptations made, there's so many you can add, and feed all this into one joint database in order to establish successful condition assessment and life cycle predictions. Formerly, we just relied on design and maintenance by regulations codes, which were not optimized or case-specific, had low flexibility, and basically relied on rather general calculations considering high safety margins. The benefit of using now actual acquisition data and case-specific information, plus the possibility to reassess and monitor building parts or materials, feeding the information in digital twins, leads to a more meaningful customized life cycle assessment and help potential reusers to identify and choose the components and parts they actually can work with in their new projects. But like I said a few slides earlier, we also contribute to the key innovations of Reincarnate by adding some self-written AI to the project, artificial intelligence. We work with our SLAMP software here and add to the valuation of recycled materials by assessing and feeding data of recycled materials to it and then assessing their relevance and reusability in terms of material properties, but also monetary value and, for example, CO2 reduction potential. By the way, if you're interested in learning more about this approach and what else can be done with it, please see the talk of Christoph Völker and me, Developing Sustainable Concretes with AI, here also at the Berlin Science Week 2022. Last but not least, Reincarnate is dedicated to demonstrating its innovations on real-world projects as well. To this end, 11 demonstration cases across Europe have been identified that will allow us to strongly demonstrate the Reincarnate methods and technologies on single construction renovation projects, within integrated business chains of contractors, real estate companies and developers. And here you see objects which were selected and how diverse they are. We encompass, for example, university and office buildings, tiny houses, a hospital, and even a wastewater treatment plant. You can imagine how different the relevant information and reuser profiles possibly are. Wrapping it up, what are the takeaway messages? The building sector needs renovation. It consumes natural resources and has a tremendous CO2 footprint. We need to foster urban mining ideas and kick off valuable urban mining approaches. In the Reincarnate project, we develop a holistic circular potential information model on the European level, involving and connecting industry and research partners across a wide variety of branches. And we hope to bring us all one step closer to our global, ambitious climate goals. I thank you for your interest and would be glad if you like to follow us on LinkedIn or Twitter. We keep you all updated on the progress of our work. Have a great and fun Science Week. Bye.